Hey guys, it's Danny here from Disrupt Tutoring, and as always, it is a pleasure to join you. In this video, we're going to do a question from the November 2019 Grade 12 Physical Sciences Paper 2. This question deals mainly with the terminology used in organic chemistry. We're given the structural formulae of two unnamed hydrocarbons, compound X and compound Y. The first question asks us to define the term homologous series. A homologous series is a group of organic compounds which have the same functional group and whose consecutive members differ by an additional CH2. So they have the same functional group, but they have a different number of carbon atoms in the longest chain. The second question asks us to write the general formula for the homologous series to which compound X belongs. So first we have to determine what compound X is. It contains only single bonds between carbon atoms and no other elements but carbon and hydrogen. In that case, we can conclude that it is an alkane. And the general formula for the alkanes is CnH2n plus 2. The next question asks us to name the homologous series to which compound Y belongs. Just like compound X, compound Y contains only carbon atoms and hydrogen atoms. Compound Y also contains two double bonds between the carbon atoms, so compound Y is therefore an alkene. Question 4 asks us to classify compound X as saturated or unsaturated. A saturated organic molecule contains all the hydrogen atoms it is possible to bond with, whereas an unsaturated organic molecule contains double or triple bonds between carbon atoms. Since compound X is an alkane, it contains only single bonds and the maximum number of hydrogen atoms. It is therefore saturated. The next question asks us to draw the positional isomer of compound X. So let's go to another page where there's more space to draw. Okay. Positional isomers have the same molecular formula and functional group, but differ in the location of the functional group or the carbon chain. So essentially, the molecule must have the same IUPAC name except for the numbers which locate the functional group and the chains. So let's write the name of this compound. It has 5 carbon atoms in the longest chain, and it also has a methyl group on the second carbon and an ethyl group on the third carbon. So that means that the IUPAC name of this compound is 2-methyl 3-ethyl pentane. Okay, so the positional isomer, we still want to have a methyl chain and an ethyl chain, and we still want it to be a pentane, but the numbers 2 and 3 are allowed to change. So let's draw the main chain of our molecules. So we have H, 3, C, CH, CH, CH2, and CH3. So it is still a pentane. It is still 5 carbons in the longest chain. And now we want to move the methyl or the ethyl chain to a place where it would give us the same IUPAC name, but different numbers. So it turns out that there's only one place we can move the methyl chain. So the ethyl chain stays where it is, CH2, CH3, and then the ethyl chain moves to the middle carbon, CH3, and then it becomes a 3-methyl, 3-ethyl pentane. So you can actually check that this is the only positional isomer by drawing the carbon chains in different places, and you will see that it gives you either a different kind of alkane, or it will still give you the exact same compound depending on the numbering of the carbon atoms. So say for example, if you had moved the ethyl chain to the second carbon, you would have CH2 and CH3, and then you would have 1, 2, 3, 4, 5, 6 carbons in the longest chain, and it would be a hexane instead of a pentane, so that's not what we want. In the same way, if you had moved the methyl group to the carbon, the fourth carbon, in the case of this compound, you would have your CH3 over here, and then the IUPAC name would be exactly the same since the carbons would be renumbered to give the chains the lowest possible numbers, so you would have carbon 1, 2, 3, 4, and 5 instead of numbered in the other direction. So you can play around with different positions for the chains, and you'll see that this is indeed the only positional isomer of compound X. Okay, so the next question asks us to describe the functional group of the compound Y. The functional group of the alkenes is a double bond between two carbon atoms. And the next question asks us to write the IUPAC name for the compound Y. So compound Y has two double bonds between the carbon atoms, meaning that it is a diene. And it has 1, 2, 3, 4, 5, 6 carbon atoms. So that means that it is a hexadiene. Okay, and now it also has a methyl chain on one of the carbons and also two double bonds. So we need to number the carbons to specify the positions of the functional groups and the methyl chain. So if we start from this side, then it gives the functional groups and the methyl chains a high number. So we want to start from this side, our numbering, so 1, 2, 3, 4, 5, 6. And that means that the functional group is on the first carbon and the third carbon, and the methyl group is on the third carbon as well. So that makes it a 3-methyl hexa 1,3 diene. Okay. The last question asks us to name the homologous series of the product formed if compound Y were hydrogenated fully. So hydrogenation is the breaking of double bonds to form, to add hydrogen, to the molecule. So if the double bonds were broken and hydrogen added to all of them, the product will be an alkane, like compound X. Okay, so before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.